what is sound control? Sound control is the ability to eliminate or reduce any unwanted noise either inside or outside of your building. And sound reduction is going to be determined by the absorption properties of the surface, so what your wall is going to be made out of. So sound levels. This chart is basically just a loudness to decibels. It's going to give you how many decibels a certain thing is making. So like, if you look at deafening, you have turbojets or jet planes, blaring radios, and it's going to give you a comment based on how somebody is going to feel while this is going on. And then you'll go down to loud and very faint. And threshold of audibility is where you're not going to be able to hear anything, and then up here is where you're going to be deaf. So this chart is just to tell you kind of how long you can listen to one thing. So based on your decibel value, you're going to look and be able to tell how many hours a day somebody can stand this before it causes permanent damage. And it's necessary to weight a sound according to its frequency, which we did there. So sound transmission. Masonry walls are highly effective when it comes to sound transmission barriers. This chart is just going to tell you, based on what you're using in your interior and exterior walls, kind of what your STD value is going to be, or your sound transmission class. So it's just going to tell you, based on your gypsum board or current or your glass bats, what kind of level you're going to be. And it's based on block size. So then the thickness of your wall, this is kind of just to show you how noise is reflected, absorbed, and then transmitted through concrete masonry walls. So these are going to be your NRC values, or your noise reduction coefficients, that you're going to use when you're calculating different things. And this is a general one that I found over just various materials. So you have your concrete, your glass, plaster, brick, and all that stuff. What kind of texture finish it's going to be, and that's going to give you an appropriate coefficient. And then also, if you're planning on painting it or putting something else on the outside, it's going to tell you how many coats to apply for percentages that you want to increase your life by. And then this one is just for block cavity walls and your STC ratings. So based on your airspace, your insulation, and the covering that you're going to put on it, it's going to give you a different value of STC, which is a lot like this chart, but just for chemicals. Okay, so calculations. So sound intensity. It's going to be your power over 4 pi radius squared. So if you were given an example, you're going to know what power is being put out. You go back to the previous charts that you got, your NRC value and your STC value, and then we're going to calculate, or you would calculate reverberation time, which is just 105 times your volume over the total absorption, and then your total absorption is going to come from the summation of your area times your coefficient. Your total area is going to be like percentage of the wall. So like if we were going to do this room, it would be the area of each wall. And then times their different coefficients that would be found in previous charts. Here are some solutions. Get excited. Okay, so sound is easily transmitted through any openings. So offsetting doors and hallways is a good way to kind of reduce those the noise. And then trying to like avoid penetrating walls, like our nice windows over there would be a good place to start. And then moving windows away from common walls on the exterior of the building. So if you have a common wall between 2 classrooms, you want to move those windows as far away from that wall as possible to help stop reverberation down the wall. Now for exterior noise, barrier walls are often used, so there's just going to be like giant concrete walls that run down the side of highways, or any kind of road that may be close to your building. And then using different types of ductwork is going to help for mechanical noise. And this is a chart that I found of just a couple of different ways that you could go about that. I don't know if I've actually ever seen some of those. But I do know in Professor Mandy's class, we're actually opted to try to use splitters and terms to help reduce noise. And then mirroring floor plans is also going to be a good way. So if you're doing a classroom building, you want to mirror the classrooms next to each other so common walls are being used for the same thing. So material solutions, acoustical wall panels, carpets, and other treatments are going to be really good. For theaters and conference rooms and things like that, you'll see a lot of different materials being used in different shapes because this is going to, one, reduce frequency. It's not going to allow for echoing, so things are going to be continuous. And then you have like drop-down ceiling tiles or clouds, and this is also going to help to reduce reverberation time and dissipate noise. These are my references, and I suggest for any serious questions that you go and ask Professor Nancy. You can find him in the architecture